All right, class, today we're going to be going over chapter 2, which is about summarizing and graphing data. So there are two areas of statistics, descriptive statistics and inferential statistics. So descriptive statistics is summarizing known population data. There's no estimating or guessing when working with this type of data, and that's what this whole entire chapter is about. We'll start looking into inferential statistics, which is when we use sample data to make inferences about a population later on in this course in chapter 7. So, descriptive statistics are numerical and graphical ways to describe and display data. Sometimes a graph can be a more effective way to present our data because then we can see where data clusters, the shape the data takes on, and it's a lot more easy for us to gain that visually than from, say, a table. So there's three different tables I'm going to talk about first. Those are frequency tables, relative frequency tables, and cumulative frequency tables. So a frequency table is a device to take a large set of data and break it up into categories or classes along with the frequency count of the scores that fall into each category. Sometimes this is called binning our data. So if I was to bin some data, I could create bins. I want them all to be the same size. So like each of these is 49 apart. And then I could count the frequency, so how often someone in this weight occurred. The total here, this total would be my sample size. So here are the weights of 31 bison recently found in Yellowstone Park. I think that's in Montana. Okay, so here's some weights of bison. As you can tell, these are pretty hefty guys. So what we want to do is we want to decide on the number of classes. Otherwise known as like bins, we're going to group our frequency data in. It's recommended that you have at least 5, but not really more than 10, because any more than 10 would make a really big table. So why don't we use 8 classes for this example? So what I want to do first is I want to find the range, which is our largest data value minus our smallest data value. And then I want to divide the range by the number of classes or bins desired. And then we have to round that last number up to some easy to use number. And that's subjective. That's up to you. If you get 8.7, you might want to round that up to 9. You might decide, oh, okay, I want to have more bins, so I'm going to round that down to 8. It's really up to you, okay? But to try for an integer, like a whole number, that would make things really nice. And try to get between 5 and 10 classes. So for our frequency table, we take our largest value minus our smallest, and we get a range of 195. We divide that by 8, and we get 24.3. Remember, we wanted 8 classes. And we're going to go ahead and use 25 as our class width, okay? Why? Because it makes it easier for us viewers. You know, we're already used to working with things by counting by 25s when we're working with quarters and things like that. So that would definitely be preferable to 24. So, fourth, we start by selecting our lowest value. That's the first number, our lower class limit, and that's the smallest number. And then we're going to add the class width to the first limit. Remember, our class width is 25 to get the second lower class limit, and repeat that to get the third, fourth, fifth, so on until we have our desired number of classes. So we're going to use 710. Note, in our data set, 711 was the smallest value, but again, 710 is a lot easier to work with. It's a nice whole number. We have a base 10 number system. So if I add 25 to each of those, I get 710 plus 25, which was our desired class width. Like, remember that. Our class width was 25. I get 35, 760, 785, 810, and so forth. Okay, and those are my 8 lower class limits. Next, I need to find my upper class limits for each class. What I do there, What I do there is here are my lower class limits, and I want my upper class limit to end one before my next lower class limit. This still has 25 values in it, right? It still has a class width of 25. So this, because we count 7 tens, it still has 25 unique values in it. So here's how we'd find our upper class limits. We then put these in a table, and we replace our tallies with actual frequencies. So I have 4 bison that weigh between 710 and 734 pounds, 4 bison that weigh between 735 and 759 pounds, and so on and so forth. Note that if we add this up, we will get 31, and that's a way to make sure we didn't miss any of the bison in our sample. Our sample size was 31, so no bison was left behind. If I want to make a cumulative frequency table, what I do is it's the sum of the frequencies for that class combined with the frequencies of all previous classes. So for a cumulative frequency, the first one's going to be 4. Then I have 8. I got that from 4 plus 4. Then I have 11, which was 4 plus 4 plus 3, right? And then I have 14, which was 11 plus 3, right here, right? 11 plus 3. And then I have 20, which was 14 plus 6. And then I have 20 plus 6. Let me write this out so we can see that because it's 26. I have 26 plus 4, and then I have 30 plus 1. Okay, so that's how we got our cumulative frequency table. When given a frequency table, you can find the class width by finding the difference between lower class levels or upper class limits. To find the midpoint for each class, you add the lower class limit and the upper class limit and divide by 2. A class boundary are the numbers used to separate classes. So let's consider our first 2 classes. We have 710 to 734 and 735 to 759. The problem is, what if there was a bison that weighed 734.3 pounds? Which bin does it belong in? The bison is between our first upper class limit and our second lower class. The upper class limit of our first class and the lower class limit of our second class. So we don't know where this poor bison goes. The class boundary would be the halfway mark between the two. And I find that by taking 734 plus 735 and dividing by 2. That's going to give me 734.5. Now, maybe you didn't need to know how to calculate that, but just in case you did, here you go. So that's going to be our boundary. So because we have a boundary here, that means that this bison is going to go into this class range. And again, here's how you find the midpoint. So our bison belongs to class 1, as I said. Here are all the class boundaries, in case you wanted to see them. A relative frequency for a table is a class that takes the frequency and divides it by the total number of frequencies, so our sample size. And the sum of all those frequencies is going to add up to 1. So 100% of the bison. So if I took 4 divided by 31, I get 0.13 or 13%, and so on and so forth for each class. If I added all of the relative frequencies up, I would get 1. And you need to make sure that they add up to 1. Not 0.99, not 1.01. You have to make sure, even if you're rounding, that they add up to 1.